आज जो स्टार्ट करेंगे हम जनरल ऑर्गेनिक केमिस्ट्री। जनरल ऑर्गेनिक केमिस्ट्री बेस से हम बता देंगे। वी विल स्टार्ट जस्ट फ्रॉम द स्क्रैच और वी विल गो अप टू ऑर्गेनिक कंपाउंड। ऑर्गेनिक कंपाउंड नोट आवाज।
Yes, sir.
What is an organic compound? Anybody? What are organic compounds?
Those components are from
Which are composed of
carbon.
carbon and hydrogen. That is hydrocarbon. I can say like this: hydrocarbons and their derivatives are organic compounds. But hydrocarbons and their derivatives are organic compounds. What are organic compounds? Hydrocarbons and their derivatives are organic compounds. Organic compounds. Now the question arises: what are these hydrocarbons? What are organic compounds? These are hydrocarbons and their derivatives. Now, what are hydrocarbons? Hydrocarbons are the compounds which are composed of carbon and hydrogen. Any compound which is composed of carbon plus hydrogen is a hydrocarbon. But any compound which is composed of carbon and hydrogen is hydrocarbon. And hydrocarbon and their derivatives we call them as organic compounds. But hydrocarbons are further classified into two types. Now, what is hydrocarbon? Compounds which are composed of carbon and hydrogen are organic compounds or hydrocarbons. And hydrocarbons are of two types. First is saturated hydrocarbon and second is unsaturated hydrocarbon. Correct? Hydrocarbons are further of two types. One is saturated and another is unsaturated. What is saturated hydrocarbon? Saturated hydrocarbons are those hydrocarbons in which the linkage, the bonding between carbon atoms is single bond. That is, carbon atoms are joined to each other by single bonds, and it includes alkanes, cycloalkanes, right? It includes, let me take the first example of alkanes. Saturated hydrocarbons are the hydrocarbons in which carbon atoms are linked to each other by single bonds, right? They contain, second point is that they contain saturation of hydrogen atoms. What they contain? First point among them is that they contain carbon-carbon single bond. They contain sigma bonds. And second point is that they have percentage composition of hydrogen is more. Percentage composition of hydrogen is more. I will explain it later on. 2 points you have to remember in case of saturated hydrocarbon, but we call alkanes. That is, in alkanes, carbon atoms are linked to each other. They are joined to each other by only single bonds, sigma bonds. And second point is that they contain, the percentage composition of hydrogen is more. Clear? Now let me take unsaturated hydrocarbon. What are unsaturated hydrocarbon? Those hydrocarbons which contain both sigma as well as pi bonds. The carbon atoms are linked to each other by sigma as well as pi bonds. These are our two types. First point is that they contain sigma as well as pi bonds. Second point is percentage composition of hydrogen is less. These are our two types. First type is alkenes, second type is alkynes. Right? Let me repeat it up to this point. Organic compound. What are organic compounds? These are hydrocarbons and their derivatives. We call them as organic compounds. Now, what are hydrocarbons? Hydrocarbons are the compounds which are composed of carbon and hydrogen. But Those compounds which are composed of carbon and hydrogen, we call them as hydrocarbons. These hydrocarbons are further of two types. First is saturated, second is unsaturated. What are saturated hydrocarbons? Those hydrocarbons in which the carbon atoms are linked to each other by only single bonds, what we call them as sigma bonds. And second point is that the percentage composition of hydrogen is more. Second type is unsaturated hydrocarbon. Unsaturated hydrocarbons are those hydrocarbons in which the carbon atoms are joining together by sigma as well as pi bonds. They contain unsaturation, presence of pi bonds. And second point is that the percentage composition of hydrogen in them is less. These are our two types, alkenes and alkynes. Let me elaborate it first, right? Let me take an example of saturated hydrocarbon and unsaturated hydrocarbon. First of all, we will take the example of this saturated hydrocarbon. If I will take example of that compound which contain two carbon atoms, I will take here alkene as well as alkyne. Both contains equal number of carbon atoms. Let me take an example of ethane. In ethane, general formula is CH3 single bond CH2. If I will take the second member of this family, it will be ethene. It will be CH2 double bond CH2. And the first member of alkyne family is styrene, CH triple bond CH. Why we call them saturated? And these are called as unsaturated hydrocarbon. What is the percentage of carbon? Here we have carbon atoms 2, we have carbon atoms 2, and we have carbon atoms 2, right? What is the percentage of hydrogen? How many hydrogens are present? 3 plus 3? How many? 2 plus 2? How many? 1 plus 1? 2. That means here saturation of hydrogen atom is more, we call them as saturated hydrocarbon. As the percentage composition of saturation of hydrogen decreases, hydrocarbon becomes unsaturated. And when the percentage composition of hydrogen decreases, the percentage of pi bond increases. Here we have 2 pi bond, we have 6 hydrogen atoms. We have 1 pi bond, 4 hydrogen. We have 2 pi bonds and only 2 hydrogen atoms. Now we will go to the definition of an organic compound again. I have mentioned that hydrocarbon and their derivatives are organic compounds, but I have explained only hydrocarbon. That also basic, right? Now what are derivatives of hydrocarbon? Let me explain this, right? For example, what is a derivative? Derivative is that compound which can be derived from given compound. Suppose here I have an alkane, this is alkene, and this is alkyne. Any compound which can be derived from this compound is its derivative. There are infinite derivatives of both alkenes as well as alkynes. Let me take an example. Suppose if I will add a halogen to it, Cl2, remove an hydrogen atom from it, what will be the compound? It will be just like this: CH3, CH2, Cl. ये रिएक्शन आगे हमें पढ़नी है कैसे, यहाँ मैं खाली डेरिवेटिव समझा रहा हूँ, क्लियर? I am removing one hydrogen. In place of one hydrogen, I have added one halogen atom. This was alkane. It was an alkane, and it becomes alkyl halide. It was alkane. Which alkane? Ethane. Now, what I have got? It is chloroethane. Similarly, if I will do one thing, I will add one hydroxide group and eliminate one hydrogen atom. What will be the compound? It will be just like this: CH2 double bond CHOH. It was alkene. Now I got alcohol. Suppose in case of an alkyne, I will add one phenyl group. It will be just like this: CH double bond C, and I will add one phenyl group. That is benzene ring to this compound. Right? I have derived this compound from this, derived this from this, derived this from this, and these compounds which are derived from original parent compound, they are called derivatives of hydrocarbon. So all these hydrocarbons and their derivatives are organic compounds. Right? Now we will start from the base. how to represent an organic compound. From that we have to start. So I will start now. Representation of an organic compound. Clear? How many formulas are present? You might have gone through this in class 10th. Carbon and its compounds, right? The representation of an organic compound, right? Now, topic is representation of an organic compound. How do we represent this organic compound? Up to this point, we have learned only what is organic compound. I have asked you, organic compound is hydrocarbon and their derivatives are hydrocarbons. Now, the second point is how we represent it. There are 4 formulas by which we can hydrocarbon can be or an organic compound can be represented. What's the first formula? First formula is molecular formula. Molecular formula. Okay, it is denoted by M. What is molecular formula? Molecular formula tells us the actual number of atoms of all elements present in the molecule of a compound. If I will take example of a pentane, for example. Pentane means it has 5 carbon atoms. How many hydrogen atoms may be present? So perhaps it is an alkane. What is the general formula of alkane? CnH2n plus 2. How many hydrogen will be present? 2 into 5 plus 2. That is C5H12. When I represent any compound in this form, how many actual number of carbon atoms are present and how many actual number of hydrogen atoms are present? We call this formula as molecular formula. So what is molecular formula? Total number of all atoms present in the molecule of a compound. Okay? That is molecular formula. Second is it is condensed structural formula. And we explain CSF. What does CSF stand for? It is condensed structural formula. In condensed structural formula, how is it different from molecular formula? In condensed structural formula, we have to mention the linkage, the bonding between carbon atoms. We have to mention that. How many carbon atoms are present? 5. We have to mention the bonding between these 5 carbon atoms. For example, here are 5 carbons. I will represent it as like this: CH3, CH2, 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 1, 2, 3, 4, and 5. It will be CH3. Right? In between, I have put only 2 hydrogen atoms. Why? Because carbon is tetravalent. It has valency 4. 2 valencies are satisfied by 2 surrounding carbon atoms, and remaining 2 are satisfied by 2 hydrogen atoms. Now calculate how many carbon? 1, 2, 3, 4, 5. And how many hydrogens are present? 3 plus 2, 5, plus 2, 7, plus 2, 9, plus 3, 12. When we mention the linkage between these carbon atoms, we call this formula as condensed structural formula. Now, third formula is diffused, or we call it as expanded structural formula. ESF. We call it also diffused structural formula, DSF, right? What is expanded structural formula? In case of expanded structural formula, the bonding between carbon and hydrogen is also mentioned. Here I have mentioned linkage, bonding between carbon atoms only, but not between carbon and hydrogen. When we mention the bonding between carbon as well as carbon-hydrogen, that is called the expanded structural formula. And it is represented just like this. How many carbon atoms are present? 5. 1, 2, 3, 4, and 5. How many hydrogens? Now we have to attach hydrogen. Carbon is tetravalent. 1 valency is satisfied. 3 unoccupied. I will mention 3 hydrogens here. Hydrogen, hydrogen, hydrogen. 2 hydrogen with this carbon. 2 with this carbon. 2 hydrogen with this carbon. And 3 with this carbon atom. That means terminal will, if it is saturated, terminal will contain 3, and non-terminal will contain 2 if saturated. If unsaturated, number of hydrogen decreases. Right? So what is expanded structural formula? When linkage is mentioned between carbon atoms as well as between carbon and hydrogen atoms, that is expanded or what? Diffusion structural formula. Now the last formula, that is most important formula, that is bond line notation. Number 4 is bond line notation. It is denoted by BL. What is bond line notation? First carbon in alkane family, that's methane. BLN is not applicable, right? If I draw any line segment, for example, any line segment, it has 2 ends. That is 2 carbon atoms. It's an ethane. Now, if you have carbon atoms more than 2, you have put it in bending form. For example, I have to mention 5 carbon atoms. It's a pentane. I will write it just like this: 1 carbon, 2 carbon, 3 carbon. It is the 4th carbon. 1, 2, 3, 4, and it is the 5th carbon. It is pentane. At every bending, you have to count the carbon. How many bends are present? It is the first, it is second, it is third, it is fourth, it is 5, and we call it as pentane. Pent for 5 and ane for single bond, it becomes pentane. Clear?
Yes, sir.
So this is the bond line notation. So there are how many formulas present? 4 formulas. What is the first formula? Molecular formula. What does molecular formula represent? Molecular formula tells us how many total number of all atoms are present in the molecule of a compound. Clear?
Yes.
For example, in pentane, we are having 5 carbon and 12 hydrogen atoms, and molecular formula of pentane is C5H12. Clear? Second is condensed structural formula. What is condensed structural formula? When the linkage or bond between carbon atoms is mentioned, what type of bond they possess? I have taken pentane, it is an alkane. If it would have been alkene, I would have put double bond between them. Or in case of an alkyne, we have to put the double bond between them. Here, linkage is single bond, I have mentioned that. I have separated carbon atoms from each other by single bond because it is an alkane, right? Now, third formula is expanded structural formula. What is the expanded structural formula? When the linkage between carbon-carbon atoms as well as between carbon and hydrogen is mentioned. When this is mentioned, we call that as expanded structural formula. Just like this. And the important one on which we have to focus more, that is BLN, bond line notation. What is bond line notation? We have to draw the bonds in the form of lines and count the bending. Each bending corresponds to 1 carbon atom. Right? Clear? Now these are formulas. I will give you a few examples. You have to convert them into BLN. Right? I will give you formulas, convert them into BLN. First is propane. Second is third is next is just like this. Can you convert it into BLN? Clear? All the 3 carbon atoms are separated, no branching, so it will be just like this composition. If the first carbon, it is the second carbon, it is the third carbon, right? Second is we have 3 carbon atoms in separate chain, 1 in bending form. So can I write this compound just like this? It is the first carbon, it is the second carbon, it is the third carbon. On second carbon, we have 1 more carbon. I will put it just like this. Okay? We have 3 carbon atoms in the separate line. How many carbons? 1 is and another. This is BLN for this compound. Okay? And now I have 1, 2, 3, 4 carbon atoms in separate line. It will be 1, first carbon, second carbon, it is third carbon, and it is fourth carbon. Now I have to put 2 carbon atoms in between. It is 1, it is 2. This is the bond line notation. This is the way how to convert given formula into BLN bond line notation. Okay? Note it down. I will give more examples. Let me give you more examples, right? Now give the one-line notation for this compound. Right? How many carbon atoms are present in parent chain? There's 1, 2, 3, 4, 5, 6 carbon. Right? I will write it just like this. Carbon numbers second, third, fourth is the fifth, and it is sixth. Clear? 6 carbons. Clear? 1, 2, 3, 4, 5, 6. On second carbon, between second and third, we have double bond. It's the carbon. Second, it is third. We have to put double bond. Clear? On carbon fourth, we have to put a methyl group. On carbon fifth, chlorine atom, and it's chlorine. On carbon 6, we have to put one chlorine atom. It's the DNA for this carbon. Clear? Let me give one more example. It's an alkyne. In case of styrene alkyne, bond angle is 180. When bond angle is 180, you have to keep, remember it, in case of triple bond, the surrounding carbon must be in same plane because bond angle is 180. And I have to put it just like this. What will be the bond line notation? But bond line notation will be, I won't be able to put the bond line notation, it's triple bond. Right? I can't put straight here, but it is straight, right? Because we have to maintain the bond angle 180. I can't put straight. I can keep this just like this. Keep the triple bond between them, then one carbon, then one carbon. Because bond angle is 180 and surrounding carbon must be straight. Okay? Can you make bond line condition for this compound? Okay. What will be BLN for this compound? How many carbon atoms in the parent chain? 1, 2, 3, 4, 5. Put 5 carbon atoms. 1, 2, 3, 4, and 5. Okay. On carbon second and third, we have to put double bonds between second and third. Here is the second, here is the third. Put the double bond between the third. On second carbon, one methyl group. On third carbon, one methyl group. And this is the bond line notation. What about this? Can you put one line notation for this compound? How many carbons? 1, 2, 3, 4, 5. First thing is that maintain parent chain, right? How many carbons are present? 1, 2, 3, 4, and 5. And 1 is carbon number first, second, third, fourth, and fifth. Clear? Now, on second carbon, we have two substituents, chlorine, bromine. I will put chlorine, bromine here. It is your choice. You can put chlorine upwards, bromine downwards, your choice, right? Or just like this. Okay. On carbon third, I have bromine. This is the carbon third, I will put bromine. On carbon, next carbon, I have fluorine attached. And next carbon contains iodine. I will keep iodine just like this. And this is the bond line notation for this. Okay?
Yes, sir.
Now, it was how to represent an organic compound. It is the basic, and it will be followed by degree of carbon. Degree of carbon. Degree of carbon. What is meant by degree of carbon? Right? Degree of carbon indicates how many times a given carbon atom is attached to other different carbon atoms. That indicates its degree. What is degree? How many times A given carbon atom is attached to other different carbon atoms. That's called a degree. And on the basis of degree, carbon atoms, we differentiate them into four types. How many types are? Four types of carbon atoms on the basis of degree. And the first type we call as primary or 1 degree carbon atom. Now what is primary or 1 degree carbon atom? It's the first type. Primary or 1 degree carbon atom is that type of carbon atom which is attached to only one other carbon atom. But that type of carbon atom which is attached to only one other carbon atom. I can write it. Carbon atom attached to only one other carbon atom. One other carbon atom. Okay. For example, CH3 single bond CH3. This carbon is attached to only one other carbon atom. This is primary. This is primary. I will mention one more example. For example, CH2 double bond CH2. Here, this carbon is attached to one other carbon by double bond. It's primary. It's also 1 degree, 1 degree. I can put this example also, CH double bond CH. Both the carbon here are 1 degree. Why? What does degree mean? To how many different carbon it is attached? It is attached to one different carbon by single bond, one different carbon by double bond, one different carbon by triple bond. Their degree remains same. Clear? Yes, and what is second? We call secondary or 2 degree carbon atom. Now what is secondary or 2 degree carbon atom? Secondary or 2 degree carbon atom is that type of carbon atom which is attached to two different carbon or two other carbon atoms. But carbon atom attached to two other carbon atoms. Two other carbon atoms. Clear? For example, can you mention the degree of this carbon? What is the degree of this carbon? Attached to one, it is primary. What about this? Two different carbon, it is 2 degree. What about this? Only one other, it's primary. If I will take example this, CH3, CH2, CH2, CH3, mention degree here. Attached to only one other, it is primary. Attached to two other, it is secondary. Two other, it is secondary. One other, it is primary. Okay? If I have to put example just like this, CH3, CH double bond CH single bond CH3, it is primary, it is 2 degree, it is 2 degree, it is primary, right? I have explained it 2, now I will be explaining third one. Third type is tertiary or we call it as 3 degree carbon atom. What is tertiary or 3 degree carbon atom? What is tertiary? That type of carbon atom which is attached to 3 other carbons. How many? 3 other carbons. So I can write it here. Carbon atom attached to 3 other carbon atoms. 3 other carbon atoms. For example, mention the degree of carbon, each carbon in this example. What is the degree of first carbon? It is attached to one other carbon, it is degree is 1. It is 2 degree. Attached to 1, 2 and 3 carbon, it is 3 degree. It is 1 degree. It is 2 degree and it is 1 degree. Right? And the fourth and last type is quaternary carbon atom. Carbon atom. We even call it as 4 degree, right?
Yes, sir.
Now what is 4 degree carbon atom?
In which carbon atom?
In which carbon atom is attached to 4 other carbon atoms, to 4 different carbon atoms. What? Carbon atom attached to 4 different carbon atoms. 4 different carbon atoms. For example, indicate the degree of each and every carbon atom. What about this carbon? It is 1 degree. What about this? Attached to 2 different, it is 2 degree. What about this? 1, 2, 3 other, it is 3 degree. What about this? Attached only 1, it is 1 degree. What about this carbon? 1, 2, 3, 4, it is 4 degree. What about this carbon? Attached to only 1, it is 1 degree. Attached to only 1, it is 1 degree. Attached to 2 other, it is 2 degree, right? And what about this? 1 degree. Okay? Can I mention it here about degree? 1 minute. Primary carbon may be represented just like this. Is it 1 degree carbon? That type of carbon which is attached to only one other carbon. What about 2 degree carbon? Can it be just like this? 2 carbon, rest 2 valencies will be occupied by 2 hydrogen atoms. It is 2 degree carbon. What about 3 degree carbon? We have to attach 3 other carbons, and the 4th valency will be satisfied by hydrogen. Clear? It will be 3 degree carbon. What about 4 degree carbon? Will it be just like this? All the 4 valencies are occupied by carbon atoms. Clear? And it is 4 degree carbon. It is the representation of carbon atom. This is primary, that means it has 1 if it is saturated. If unsaturated, number of hydrogen will decrease. It is attached to 1 carbon and the rest 3 unoccupied valencies satisfied by hydrogen. In case of 2 degree carbon, 2 valencies are satisfied by 2 hydrogen atoms, the rest 2 by 2 hydrogen. In case of tertiary carbon, 3 valencies are satisfied by 3 carbon atoms, 4 is satisfied by hydrogen. And in case of 4 degree carbon, all the 4 valencies of carbon are satisfied by carbon atoms and there is no hydrogen atom. Okay? Why? Because carbon is tetravalent. No need. Any doubt? Clear? Now it will be followed by degree. I would mention that. I will ask you, what is the degree of hydrogen? Right? Degree of hydrogen depends upon the degree of carbon. Right? Degree of hydrogen directly depends upon the degree of carbon. If hydrogen is attached to primary carbon, we call it as primary hydrogen. Those hydrogen atoms which are attached to secondary carbon, we call them as 2 degree or secondary hydrogens. And those carbons which are attached to 3 degree carbon, we call them as 3 degree hydrogens. Clear? Can 4 degree hydrogen exist? No. Why? Because all the 4 valencies are satisfied carbon, therefore 4 degree hydrogen does not exist. So here I can put it here. We have 1 degree hydrogen, we have 2 degree hydrogen, we have 3 degree hydrogen. Whereas 4 degree hydrogen does not exist. Why? Because carbon is tetravalent. All the valencies are satisfied by carbon itself, and there is no unoccupied valencies. Right? And what about this CH4? I have mentioned that primary carbon is that type of carbon which is attached to one other carbon. But this is also, we call it as a 1 degree carbon. It is not attached to any other carbon atom. It is the suppression in literature, we call it as super primary carbon. What is it? Super primary carbon. Super primary carbon, nothing but only 1 degree carbon, right? That type of carbon which is not attached to any other carbon atom, we call that as super primary carbon. Clear? Now it will be followed by exercise. I will give you brief exercise upon number of primary, secondary, tertiary, 4 degree carbon as well as hydrogen atoms. Clear? I will put a few examples and you mention it. And I will give the all examples in BLN form, bond line notation. The basic, right? We haven't started GOC yet. It is the basic. Probably from third lecture we will start general organic chemistry. I am clearing these basics which you should have gone through in class 10. Right? Now, let me give an example. But I will put 5 examples to clear this topic further. Examples. Here you can put 1 degree carbon, 2 degree carbon, 3 degree carbon, 4 degree carbon, 1 degree hydrogen, 2 degree hydrogen, and 3 degree hydrogen. I will give all the examples in Violin form, bond and division form. Correct? How many primary carbons are present? Only 2, right? This is the primary carbon, this is the primary carbon. So we have primary carbons 2. How many primary hydrogens? Listen, if compound is saturated, primary carbon always contains 3 primary hydrogens. Therefore we have 3 hydrogens here, 3. Total 6 1 degree hydrogen atoms. Okay. How many 2 degree carbons are present? 1. How many 2 degree hydrogens are present? If it is saturated 2. Okay. Because carbon is tetravalent, 2 valence are satisfied by 2 surrounding atoms, the rest will be satisfied by 2 hydrogen atoms. So we have 2 degree hydrogen atoms. How many 3 degree carbon? 0. How many 4 degree carbon? 0. How many 3 degree hydrogen? 0. Is it clear? Yes. I will give you a few examples, then you can do the rest. If I have compound just like this. Okay. How many primary? First of all, find primary carbon. Is it primary? Is this carbon primary? Is this carbon primary? How many primary carbons are present? 3. Okay. Here we have only 3 primary carbons. Are they saturated or unsaturated? All are saturated. If they are all saturated, how many hydrogen they will contain? 3 into 3? 9. Okay. So primary hydrogens are 9. I will write 9 here. How many 2 degree carbons are present? Is this 2 degree? Clear? Is this 2 degree? So 2 degree carbons are present. But here hydrogens may differ. This secondary carbon is saturated, it contains 2 hydrogen atoms. It is unsaturated, it will contain 1. 2 plus 1. How many 2 degree hydrogens? 3. Clear? Is it clear? Clear? How many 3 degree carbons are present? Only 1. It is 3 degree carbon. 1. How many 3 degree hydrogens? If it would have been saturated, it must contain 1 hydrogen. But it is unsaturated. It does not contain any hydrogen. Why? This carbon contains all the 4 valencies. 1, 2, 3 and 4. So 3 degree hydrogens are 0. How many 4 degree carbon? 0. Okay? Yes. What about this compound? Swastik sir. How many primary carbons are present? 1, 4, 3, 4. How many primary carbons? 1, 2, 3, 4. Clear? It has 4 primary carbons. All the primary carbons are saturated. How many primary hydrogens are present? 4 into 3. 4 3s are 12. So we have how many? 12 1 degree hydrogen. How many secondary carbons? 4. Is it secondary? Yes. Is this carbon secondary? Is this carbon secondary? Is this carbon secondary? How many secondary are? 1, 2, 3, 4. All are saturated 4 into 2. How many secondary hydrogens? 4 2s are 8. So we are having 8 secondary hydrogen atoms. How many tertiary carbon? Is any carbon tertiary? No. Tertiary carbon 0. Therefore tertiary hydrogen also 0. How many 4 degree carbon? 1. Only 1. It is 4 degree. It is 1. Can you calculate primary secondary carbon in this compound? Calculate. How many primary carbons are present? First of all, is this primary? Is this primary? Is this primary? Clear? Is this carbon primary? Is this primary carbon? Is this primary carbon? Now calculate how many? 1, 2, 3, 4, 5, and 6. But Fu are saturated, Fu are unsaturated. 3 plus 3, 6. 6 plus 3, 9. 9 plus 3, 12. 12. Then go to this. Plus 2, 14. Plus 2, 16. So primary hydrogens are 16. I will repeat it again, right? 1, 2, 3, 4, 5, 6 carbons are primary. But when we have to find out primary hydrogens, this is saturated, it will contain 3. Saturated 3. Saturated 3. 3 plus 3 plus 3, 9. 3 plus 3 plus 3, 9. Plus 3, 12. Plus 2, 14. Why 2? Because this is unsaturated. Plus 2, 60. Right? How many 2 degree carbons are present? Is it secondary? Is this carbon secondary? Is this carbon secondary? Is this carbon secondary? Is this carbon secondary? Clear? Is this carbon secondary? Then this carbon secondary. Then this carbon secondary. Calculate how many carbons are secondary? 1, 2, 3, 4, 5, 6, and 7. We have 7 carbons 2D. Now we have to find out secondary hydrogen. Is it saturated? 2 plus 1 plus 1 because it is double bond. Secondary carbon 8. 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. Sorry. We are having 8. Now find out secondary hydrogens. 2 plus 1. Why 1? Unsaturated. Because go to the balance sheet. Carbon is tetrahedral. 1, 2, 3. Only one hydrogen. Clear? 2 plus 1, 3. 3 plus 2, 5. 5 plus 2, 7. 7 plus 1, 8. 8 plus 1, 9. 9 plus 1, 10. 10 plus 1, 11. We have only 11 2 degree hydrogen. Check it again. दोबारा चेक करो ना. देखिए इसका एक हुए 2, इसका एक हुए 3, इसका एक 4, 4 और 2 6, 6 2 8, 9 10 और 2 sorry 2 11. Correct? How many 3 degree carbons are present? Is this 3 degree? Clear? Is this 3 degree? Is this 3 degree? How many 3 degree carbons are present? 3. 4. Sorry. We have one more. Is this 3 degree? Right? We have 4 3 degree carbon atoms. How many 3 degree hydrogens are present? 1, 2, 3. Only 3? Not 3. It is tetrahedral. 1 2 3 4 ये पूरी वैलेंसी सेटिस्फाई कर रहा है. जहां डब्ल्यू पढ़ना है वहां नहीं करना हाइड्रोजन. क्लियर? हाउ मेनी 4 डिग्री कार्बन आर प्रेजेंट? 0. नोट इट. आई विल डू टू मोर एग्जांपल. हो गया? चलिए फिर मैं कुछ और एग्जांपल करता हूं. चलिए इसका बताइए. मैं एक साइक्लिक कंपाउंड बोल रहा हूं. How many primary carbons are present? Only one. Clear? And this is the primary carbon. Primary carbon is only one. And how many primary hydrogen will be present? Only 2. Why? Because it contains double bond. Primary hydrogen are 2. How many 2 degree carbons are present? Except this, all carbons are 2 degree. Right? It is 2 degree. This is 2 degree. This is 2 degree. Leave this one. 2 degree. It is 2 degree, 2 degree, 2 degree, 2 degree. How many 2 degrees are present? 7. 1, 2, 3, 8, 4, 5, 6, 7, 8. We have 8 2 degree carbon. How many 2 degree hydrogens are present? Out of this, the rest are 7. 7 into 2, 14. 14 plus 1, 15. Check it. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 2 degree hydrogens are 15. How many 3 degree carbons are present? Only one. This is a 3 degree carbon. 3 degree hydrogen is also 1 and 4 degree carbon is 0. What about this compound? I will put some. Find out. How many primary? First of all, find out primary. Is this primary? Is this primary? Is this primary? And this carbon is primary. Calculate. 1, 2, 3, 4. Are all the 4 primary carbons saturated? 4 3s are 12. So we are having 12 1 degree hydrogen. It's 12. How many 2 degree carbons are present? Is it 2 degree? Is this 2 degree? Is this 2 degree? Is this 2 degree? This is 2 degree. This is 2 degree. This one 2 degree. 2 degree. 2 degree. 2 degree. Calculate how many are present 2 degree. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are having 10 2 degree carbons. How many 2 degree hydrogens are present? Only 1 2 degree, 2 degree carbons are unsaturated.
19.
Rest 8. 8 2s are 16. 16 plus 2, 17, 18. We have only 18. How many?
2 9s is 18 plus 1.
18 18 2 degree hydrogen है. 2 4 6 8 9 10 11 12 13 14 15 16 17 18. Clear? How many 3 degree carbons are present? How many 3 degree carbons are present? Is it 3 degree? Is it 3 degree? 3 degree carbons are only 2 and both are saturated, therefore 3 degree hydrogens are also 2. How many 4 degree carbons are present?
1.
Is it 4 degree?
Yes, sir.
It is 1. Okay. What about this carbon? How many primary carbons? Only 3.
Yes, sir.
Is it 1 degree? Is this 1 degree? Is this 1 degree? So we are having 3 primary carbons. How many primary hydrogen? 3 2s are 6. 6, right? We are having 6 1 degree hydrogen. How many 2 degree carbons are present?
1, 2, 3.
1, 2, 3. How many 2 degree hydrogens? 1, 2, 3. There are also 3. क्यों 3 है भाई? क्योंकि वैलेंसी कार्बन की 4 है ना, 1 2 3 एक ही कार्बन. How many 4 degree? How many 3 degree carbons are present?
1.
Only 1. 3 degree carbon is 1. 3 degree hydrogen is 1 and 4 degree carbon is 0. इस पर प्रैक्टिस कर लो, रेस्ट इंशाल्लाह कल के लेक्चर में. क्लियर?
Yes, sir.